Hey, it's Mr. Day, and you know what we're doing. Final exam review time. Final exam review packet, in the first part, the first page, is looking for X, solving for X, and then finding out how many solutions. One, none, or many. One solution means X equals a number. No solution means we get an absurd, crazy, ludicrous answer like 5 equals 10. It doesn't work. Or we could get 5 equals 5, and that would be infinitely many solutions, because 5 is always equal to 5 no matter what we do or say. Here we go, let's do number 1. On this one, notice we have -5 and -5 on each side. So we would love to just eliminate those two, and we can by adding the opposite. Opposites cancel. What does that mean? Well, -5 plus 5 is 0. So essentially, they're not really canceling, they're dissolving to 0. And now that simplifies everything. 4x equals x plus 3x. Collect like terms, we get 4x equal to 4x. And this is what we're saying. No matter what we put in for 1, if x equals 1, then we have 4 times 1 equals 4 times 1. 4 equals 4. That's true. Therefore, 1 is a solution. But we can do that with any number. If x equals -1, then we get -4 equals -4. Similarly, if x equals 0, we get 0 equals 0, right? Because 4 times 0, if you want me to write it out, I can, equals 4 times 0, and then we get 0 equals 0. In other words, that's also true, and this is true, and this is true. Whatever number we pick, we get a true solution. Therefore, every number is a solution, and we put infinitely many solutions. And that is the reason. So whenever we get 4 equals 4, or 4x equals 4x, or 10 equals 10, or 100 equals 100, or 0 equals 0, this is infinitely many solutions. Some students get confused. They get 0 equals 0 and they think no solution, or x equals 0. That's not true. This would always be infinitely many solutions whenever we have what's called an identity. One side is equal to the other side. So on this question, we have, first of all, collect like terms. This is an invisible 1. Always put that 1 in there. That's going to add up to be -5x minus 7 equals -2x plus 5. We're going to take the numbers and get them all on the right, and we're going to put the x values and put them on the left. And here we go, -5x. This is now 0. We're dissolving into 0. We don't usually write it, but we could. And that equals -2x plus 12. Now, we want to get the x's over here, plus 2x, and we get -3x equals 12. What do we do now? We're solving for x, right? And the -3 is the only thing in the way. Just divide it on both sides, and we get x equals -4. Well, what is that? That's a solution. And there's only one of them. It's called a unique solution. So this is one, actually unique solution, because there's only one in the universe that will supply the solution for this equation. And if you were to put that in, to solve it, like to check it, you could do that. You would go -1 times -4. I'm just plugging in the -4, minus 4 times -4, and then -7. And then you ask yourself, does it equal the right-hand side, -2 on the -4 plus 5? You're asking the question, is this a solution? I bet you it is. Of course I know it is. -7, is that equal to 8 plus 5? Hold your breath, ladies and gentlemen. Let's see, 20 minus 7 equals 13, and indeed it is. And that proves that that is one unique solution. That's the name of the game. This is just a check to do it. You should always do a check. It really helps you. Let's look at number 3. So now this one, well, again, we're looking to collect like terms, but they're not together, so I like to commute things. So I'm going to write 5x, move that -7x over here. That 3 goes over here, plus 3 minus 4. And over here, I'm just rewriting this, okay? And what I did was called the commutative property. Very important to know what you're doing at each step. So 5x minus 7x minus 2x plus 3 minus 4, minus 1. 2x minus 4x is negative 2x. Be careful with the integers. 2 minus 4 is negative 2, not positive 2. Plus 1. What was that? That was collecting like terms. I'm going to write CLT. So get used to collecting like terms as CLT. What is going on now? We have a mirror image. This side is equal to that side. So that sounds, oh, it's not quite the same. I'm almost fooling myself here. It's not quite the same. I thought it was for a moment. But what we can do is say, okay, that we can just go ahead and dissolve into 0, where f, that's 0, 0. So now we have negative 1 equals positive 1. That seems a little strange, and in fact it is strange. That's not true in this known universe. That's not true. There may be some galaxy where that's true. There may be some system of numbers which is defined that way, but we don't know it. We don't recognize it. So for us, this is called false, all right? And when it's false, when it's not true, that means there is actually no solution. There is no number in the universe that we know of that will make that true. There's nothing we can do. If I pick x equals 0, then this would become 3 minus 4 is negative 1 equal to 1. And again, it would be false. I could pick any number in the universe and put it in for x. I could never get it to be true. So that's why that's no solution. And there's the case right there. Last but not least, is 3, 8 a solution of 2x plus 1 equals y? It's very simple to answer this. This is a ordered pair, x and y. And if there were two of them, we'd put x1, y1, x2, y2. But there's only one, and there's only one thing you can do is substitute that into here. So we're going to go 2 substitute plus 1 equals substitute into y. What do we substitute? That 3 and this 8. And we put a question mark there because now that we've substituted numbers, we're asking the question, is this a solution? Is that what is going to make this work? So 6 plus 1, is it equal to 8? 6 plus 1, sorry. And in fact, it is not a solution, therefore. So as we ask that question, 7 does not equal 8. Therefore, no. The answer is no. It's not a solution. Not a solution. So it's very similar to what we did with the check. You know, we wanted to put that number back in, and we see it doesn't work, so therefore we can't say that's a solution. It was back what we did here. So when we saw that x equals negative 4 is a solution, and we wanted to check that, we simply put that negative 4 in for x, and we checked it, and it worked. Whereas in here, it didn't work. The difference is this is an ordered pair. It's a point on a graph. And this is an equation of a line. It's in y equals mx plus b form, actually. Usually we might write it like this, okay? So we might write it like this. But for this question, it doesn't matter which order you write it in, because all you're really checking is to see if that point will work. Will it be a solution? If it were a solution, this would have to equal that. It's not, it's false, it's not a solution. So these are the different possibilities, infinitely many solutions, one unique solution, no solution, and all of those things come into play when you're working with solving for x. So solving equations. Remember, collecting like terms, commutative property, that things dissolve into 0 when they're opposites. Those are your basic principles, and just try to remember to use negatives and positives when you're adding and subtracting integers. Be very careful to double check those, because a lot of mistakes happen in just the arithmetic of integers. You know, just believe it or not, 2 minus 4, and getting those things right. So that's one of the types of things that you have to know for the final exam. Let's move on to some more fun stuff.